Welcome to a short video on how to change a bandpass filter into an oscillator. This is specific on our KRC filters. Most of them has positive feedback, so at a specific gain we can get them to oscillate. Okay, so I'm going to use the bandpass filter to do this. So first we're going to look at how, then at some limiting techniques that you can employ, alternative approach, and then some simulations. Right, so first up, if we look at the KRC bandpass filter, if the gain approaches 4, okay, so RB over RA plus 1, if that approaches 4, our Q goes to infinite. Right, so if we push our gain past 4 volts per volts, our circuit will start to oscillate. Right, so if we ground the input and we push the gain beyond 4, we have oscillator. So picking RA 1 kilo ohm and RB 3.09 kilo ohms, we will already have our oscillation ready. Okay, so we can start getting oscillations. So picking R3, R2 and R1 the same values and the same capacitors, we can pick an oscillation frequency. Okay, so for 10 kilohertz, 2.24, 10 nanofarad capacitors, and we have ourselves a 10 kilohertz oscillator. Right. So with this input resistor grounded, we will have oscillations, but our output will go to the saturation limits of the op amp. So one method of limiting is putting two diodes across this input resistor, which will limit the input here to plus minus 450 millivolts roughly. And on the input we will have some losses. Multiply that with our gain over here and we will have output of plus minus 1.5 volts at the output of this oscillator right here. You can also have multiple diodes or Zeners in this position right here. Go and look at the limiting circuits for my oscillator videos, and there is more techniques how to do this. Guys, even the non-linear limiting techniques, how to reduce this gain and bring our amplifier back to stability. Right, so that is one limiting technique. The second technique is not really limiting, is to take this filter and limit its output to this diode voltages. So one limiting resistor so that we don't burn out our diodes, and the output here will be limited to plus minus 700 millivolts. And then you can design a second bandpass filter with a high Q value and take this 700 millivolts and convert it to whichever output you want here, 5 volts or 6 volts, 4 volts, whatever you want, and filter the output from this now oscillator, which is limited, so we will have kind of block waves. Put it through a bandpass filter and we will have nice sinusoids coming out. Okay, so this resistor values here is to correct the gain, so 700 to 5 volts, and the capacitors and the resistor values is for the Q factor selection and the center frequency at 10 kilohertz. So these are two bandpass filters, different kinds, designed for the same frequency, but this one is pushed to oscillate, and this one will not really oscillate. So let's jump over to the simulations and let me show you these two circuits working. Before I can go to the simulation, I should probably go over the solution for the resistor values of the second filter. So for a Q of 100, we can calculate all the component values, which you already saw. And this thing requires a gain of 20,000. And from there, we can design the two input resistors. If we want a 5-volt output from a 0.7, we can design for 7.14 volt per volt gain. And that gives us a 22.3 kilo ohm RA and RB at 7.96, which was the original value in any case. If the voltage is not correct on the output side, you can just tune R1A down a bit and your output will increase in voltage. And now we can jump over to that simulation. Here I have two oscillators built, so I'm going to run this oscillation, the simulation, and then show you the different outputs. Okay, with our simulation complete, let's have a look at the first one. So there's our output at 1.5 volts. You can see the signal is slightly distorted. And we can have a look here at the input, about 450 millivolts, and we have some losses going into the amplifier, and then it goes to 1.5 volts right there. The second one right here, we are clipping our output across these diodes, and then we put it into our filter at a much smaller value right here. It already looks sinusoidal because it has been filtered and fed back, and that gives us our 5-volt output that we wanted. So let's take the separate or the two filters and let's do FFTs on them. Take both. Okay. 02 is a blue one. So this is the one put through the bandpass filter. And this one is the limited oscillator that we have here. There is less noise on the second one than the first. So these outputs look kind of nice. And there's how you take a bandpass filter and convert it into an oscillator. And if you want pure outputs, just put it through another bandpass filter like that. And that is it for bandpass to oscillators. Thank you for watching.